So we're here to talk about Gaudi and the DL1 instance on Habana and the DL1 instance on EC2. Before we start, I just want to get a quick read of the room. How many of you have done any work on Gaudi at all? Any show of hands? Or this is new for all of you? Excellent, you were in the right place. So my name is Greg Suraki. I'm an applications engineer from Habana Labs.
And my name is Dwij Vajpayee. I'm a senior product manager at Amazon EC2. And yeah, today we're really excited to tell you about our DL1 instances, which are purpose-built for machine learning in the cloud. So we'll first start off and do a quick overview of the DL1 instance and its specs, and talk a bit about its design and the thinking behind its design. We'll then run through a few demos to showcase the usability and the capabilities of the DL1 instances. And finally, we'll talk about some of our customers using DL1 today and some of their use cases. So the DL1 instances are built on the Intel Habana Gaudi chips, which are purpose-built for machine learning training, as Greg will talk about in a bit. Greg, do we have a chip right there?
Absolutely. This is it. You guys can come take a look at it afterwards. This is it.
So that's what it looks like. In the server, it'll actually have a giant heat sink on it because it generates a lot of power as it's going through its calculations. And so as you can see from the diagram, we have 8 of those chips per server, and they're connected in a full mesh topology. So that allows robust all-to-all communication between the chips, which creates more efficient distributed training for those customers that train models not only on one chip, but across multiple chips as well. So the other thing we did on the server is that we included probably amongst the highest networking bandwidth that we have in our portfolio at 400 gigabits per second. And what we anticipated was that a lot of our customers would train not only on one instance, but train the same model on multiple instances to improve ML training throughput. And finally, we have 4 terabytes of local storage on these instances. And this helps machine learning engineers and scientists cache more of their data locally, which helps simplify and optimize their training workflows. So this slide really speaks to the core value proposition of DL1, which is price performance. What we've seen over the past 5 to 7 years is that the complexity and scale of ML models and the data sets has increased rapidly. And with that, there's been a concomitant increase in training costs as well. And this is something that our customers told us a lot about. And they said, hey, Amazon, can you give us some more price-performant training options so that we can make more of our ML budgets? And so that was really the genesis of our partnership with the Habana team, is we thought, OK, how can we design from the ground up an instance that's optimized for machine learning training? And so over here, you can see where we've been able to achieve strong price performance over state-of-the-art GPU instances, both on the vision side and on the language side. We see 40, 50, 60% traditionally for a range of models, and we can talk about the different models that are supported later on in the presentation. But enough talk, Greg. How about we get one of these up and running?
Let's get one up and running. So let's get a model running in 5 minutes or less. What we have here is a Jupyter notebook that's running on the DL1 instance today. And we're going to show you a very, very simple PyTorch model to get started and run the workload. So let's start with some boilerplate stuff. This is coming directly from PyTorch. We stole this model from PyTorch library. So we're installing some basic stuff. Here we're incorporating some of the boilerplate PyTorch information that you need to run a model. And then we hit the most important part of this, which is this line right here. So we're going to import the Habana library, which is our Habana PyTorch library. So this gets imported as, in this case, HT core. And we set the device, HPU device, to the model. HPU stands for Habana Processing Unit. So this is a key part of making sure that the model knows to execute and run its workload on Gaudi. These are the two steps that you include in your model when you transition a PyTorch model running somewhere else to running on Gaudi.
Pretty easy.
Easy stuff. All right, so let's look at a pretty simple data set. So in this case, for this example, we're downloading the Fashion MNIST data set. So it's really simple. We set our data loader in this case, so very simple PyTorch default data loader. And let's create the model. Now in this case, this is a very simple linear regression model. It's not meant to be doing anything other than a simple example, but let's run it. And we know we're printing the model, so we're printing, and it's showing us that it is using the HPU device. So we know that this model is going to run on Gaudi. And for any model, obviously, we need to set a loss function and an optimizer. So we're using pretty boilerplate cross-entropy loss and stochastic gradient descent. And then we run our trainer. Now, there's one key thing here that is really a great feature of Gaudi, and that is the optimization about how the model actually runs. So in most cases, what Gaudi is doing is, and what our software stack is doing, is collecting ops in a large graph. And if that graph doesn't need to be run at a certain time, the graph will hold off. And the only time it will run is when it's needed by the kernel. So in this case, we have two functions that we call. The function is called mark step. And what this mark step is doing is simply coalescing all those graphs and running them in the model. So for you, when you run your backward pass or run your optimizer, we want to make sure that all of the graphs are replayed and rerun in the model. So that's the other part that you need to add to your model. So let's run that.
And so, Greg, that basically improves the ML performance and the throughput.
That's a performance and throughput improvement. That's right.
Awesome.
So then we set our test function, and test function here. We set our training function. And now all we're going to do for 5 epochs is run the training and run the test. Let's see what that looks like. And we see, in this case, we're going to run 5 epochs, and we'll see that the loss is going down. But the cool part here is 4 lines of code, and you're running on Gaudi.
Yeah, one of the things our customers told us is, OK, this looks great, but can you make it easy for us to migrate our workloads? And that's something that we focused on very closely with the Habana team, building out that customer experience to make it as seamless as possible.
And we'll let that finish, and we're done. So let's go back. So again, to summarize, when you work with PyTorch, it's 4 things. It's importing the Habana PyTorch library, it's setting the device to HPU, and including those 2 mark step commands at the end of the backward pass and the optimizer run. Now, for those of you that are running TensorFlow, we have you covered. So the TensorFlow architecture is a little bit different in this case. So here we are loading the Habana module, which is built into the TensorFlow library, and simply calling that Habana module, load Habana module. And again, same thing as PyTorch, it's simply allowing all of the ops to run directly on Gaudi. So very simple, very straightforward.
Awesome. So yeah, let's talk a little bit about the models and what this instance can do. And this was a key source of collaboration between Amazon and Intel Habana, where we were able to provide guidance to the Habana team in terms of what models and operators to build out to meet the needs of our most cutting-edge ML workloads and most sophisticated customers. And so that's an ongoing process, and we continue to build out the model and operator support every day, building on the wide range of models that are supported today. The other key piece of collaboration was taking these models and working with our EFA team, working with our networking teams to actually scale it up, as I was mentioning earlier, not only across multiple accelerators in one instance, but indeed to multiple instances as well. And we invest a lot on both sides into making that performance linear so that you can turn the price performance benefits into raw performance benefits by just scaling out to however many nodes you need to get to the throughput that you require to hit the time to train metrics. So Greg, can you tell us a bit about the different models that are supported today and how people can get up and running and interact with them?
Absolutely. So we really want to focus on these 3 areas you see here on the screen: computer vision, natural language processing, and multimodal. So computer vision is your typical image segmentation, image recognition. And in our demo in the showcase, you'll see us showcasing our partnership with Mobileye. So Mobileye is an autonomous driving company that they train their models on Gaudi, on the DL1 instance, and then deploy those models in their car for inference real time. So they train their models very, very regularly and have great performance. Now, for natural language processing, this is really the growth area we all see today. And this is one area where we're spending a lot of time focusing on those typical use cases you see on the screen. We've additionally are investing in larger and larger models. So we'll show you in our GitHub page, we have a BERT 1.5 billion and a BERT 5 billion parameter model. We're looking at GPT-2, GPT-3, Bloom parameters to train larger and more complex models. And this requires us to need that horsepower that's available in the DL1 instance to be able to manage and train those humongous models. Finally, multimodal. We're seeing this evolution now as a mixture of text, object detection, text-to-speech, the combination of these use cases. One really fun use case here at the expo in the AI neighborhood is a demo of our stable diffusion model. So we have our stable diffusion model running on inference, so you can go to the terminal, type in anything you want, and it creates really cool pictures based upon whatever you type. Those are really fun.
Important point there being that we can not only do training, but also inference on Gaudi as well.
All right, so we've talked about a very simple model to get you started, but that's not going to help you apply your workloads. Let's talk about some real models. How does it apply to reality? So we want to talk about our GitHub page. So we'll show you that in a moment. We have about 50 models across TensorFlow and PyTorch that are pre-built, optimized, and ready to run. So you can get started if you just want to play with the instance and see how it works and get comfortable running it, or take our models as a baseline and then grow and apply it to your own workload. So let's take a look. So let's go, before we do the notebook, let's go to our page. So this is our GitHub page. And what you'll see here is a mix of computer vision across TensorFlow and PyTorch, and all the traditional models here that you probably would be using in your workloads. We have natural language processing models here, so all the traditional suspects. Again, the new one here is our deep speed model, so we are investing in deep speed. And additionally, not only here on our model garden, we have a very strong partnership with Hugging Face. So for those of you that are using Hugging Face transformers, we have a very strong partnership with Hugging Face, and now basically the 40,000 transformer models that are running on Hugging Face can run on Gaudi on the DL1 instance.
Yeah, and I think there's also like an alignment of philosophy there, right, Greg, between Hugging Face and Habana, which is, can we democratize AI? Can we build a more diverse like chipset to run and train ML models? And can we lower the cost to reduce the barrier of entry for developers to get started running, training, and deploying machine learning models?
Absolutely.
And so this, when we talk to customers, we typically point them to the docs page, Greg, docs.habana.ai, and then we point them to this as an entry point so that they can go in there, see what's supported, see if it's already supported right out the box, and then tune it to their needs.
Absolutely. So let's get started with one of them. And let's pick BERT fine-tuning. So this, as we mentioned with Hugging Face, this is a Hugging Face BERT model. And what we'll show here is that we can take, we know that the BERT model was pre-trained on the Wikibooks corpus data set. And what we're going to do is in 2 minutes, we will apply the squad data set to that model and make it functional and performant on squad. So in this case, you can use this for a chatbot, Q&A, those kind of use cases. We also have examples here for MRPC. So if you're running a glue type workload, then this is another example. Now, the cool part about our GitHub page is that there are all kinds of examples here. So it's really drop dead simple, copy, paste, and run, which is what we'll show you right now. So the example we're going to do that we did copy, paste, and run is the squad data set using bfloat 16 mixed precision on one Gaudi. So let's take a look. So as we start here, we've already cloned the model references into this notebook. So all we're going to simply do is set some environment variables, go to the directory itself, install a few required libraries, and of course, the most important one here is obviously transformers. So we're including the transformers Hugging Face library. And all we have to do then is take that set of instructions, that Python 3 or that Python command, copy it from the GitHub page, we put it right here, and off we go. one other thing to notice or to mention here is we're always going to pass in that HMP for mixed precision, and very specifically, use HPU. So remember earlier we talked about HPU is our device name, right? So we want to make sure we're passing that parameter into all of our models. So when we do a call, when we do the original Python command, we want to make sure that we're using use HPU. And this sets it up and makes sure that all the model is running on Gaudi HPU. So let's run it. Now, while that's running, let's take a step back and talk about Gaudi hardware. So let's take a minute and talk about hardware and software. Let's remember that Gaudi is not a GPU. It is a dedicated, purpose-built ASIC for deep learning training and inference. So it is fully optimized and designed from the ground up to be the most efficient, cost-effective AI training device. So there's 3 key points we want to walk away from. One is our 8 tensor processing cores, which handle all the ops and flows. Our matrix multiplication engine, which handles all the convolution, which you'd see in things like object detection. And then on the edges, our high bandwidth memory. So we have 32 gigabytes of high bandwidth memory. So this ensures that the entire model stays inside the device. We don't have CPU fallback. We don't have to go to system memory. Everything is trained and managed on the same device for best performance. And finally, the most innovative part, or the part that really stands out, is on the bottom. You'll see 10 times 100 gigabit Ethernet. So Gaudi has 10 100 gigabit Ethernet ports on die. So in this case, the picture that Vij showed you at the beginning of the presentation, where all 8 Gaudis were connected, we're not using a separate host NIC. We're not using a separate controller. So this drives down implementation cost at the system side, as well as improved performance, because now there's no overhead to go to a third-party NIC device. It's direct connect, so on the DL1 instance, when you get 8 Gaudis, all 8 are totally connected through this interface.
And then we're able to pass those savings on to our customers and have them train at the highest level of performance, but at a way better price point.
Yep. Now, most of you probably are more interested in the software stack, so let's talk about that. So we call our software stack Synapse AI. And this is designed to support PyTorch and TensorFlow. And it's designed to make it very easy. You don't have to worry about ops. You don't have to worry about runtime. You don't have to worry about managing graphs or kernels. All that is being done by Synapse. All you have to do is bring your PyTorch model, bring your TensorFlow model, do those migrations we talked about a few minutes ago, and in most cases, you're really up and running and performant right out of the box. But there are a couple key points here. We have our own graph compiler. We have the Habana communication libraries. So we talk about how we use a nickel-based version that is meant for scaling across nodes and across multiple nodes. We have our own kernel library. For those customers that want to really fine-tune their kernels for the most optimum performance, we also have that purple box, which is our customer kernel library. So you can actually write your own kernels if you want. So we have a full tool set and capability to do that. But in 99.999% of the cases, you're going to take your PyTorch model, your TensorFlow model, and you're going to migrate it over to Gaudi, and you're going to run, and you're going to be performant.
Yeah, so I think customers are able to just get up and running right away with what's off the shelf and start training and see benefits there. Or as Greg mentioned, they can go into the custom kernel library and write their own kernels if they really want to optimize performance to further save on costs.
Another thing, David, we can talk about is our suite of AMIs and Docker images.
Yeah, and that's been another area of continued collaboration between the Habana team and Amazon, where we have DL armies, deep learning armies. We have deep learning containers that support Gaudi to help customers get up and running right out of the box. And so our teams work closely together. Every time there's a new Synapse release, within a couple of weeks, we make sure that there's an army that supports it. And then we have a bunch of containers that you can use to get up and running quickly.
Yep. And for those that are really interested in really scaling or using Kubernetes, we could talk about the innovation we've done on Kubernetes as well.
We see this as a trend in machine learning that a lot of folks are using Kubernetes. And so, yeah, with Gaudi, you can get started with EKS, which is our managed Kubernetes service, to manage your orchestration and deploy at scale.
All right, so we left our pre-training. So let's go take a look back and see where we left off. So we initiated the pre-training. And through some of the initializations and setup, you'll see we're, again, using Hugging Face here. So Hugging Face is loading all their libraries. And then finally, loading their initial weights. So that all gets loaded. And then we start to see the fine-tuning. And that starts right here. And so as you go see here, you see the loss continuing to go down. You see our learning rate continuing to get narrower and narrower and be more refined. So we're finding those local minimums and making sure that we are fully optimized. And so finally here at the end, we are completed. We have a nice loss here of about 1.5, which is pretty good. And it only took 1 minute and 54 seconds. How cool is that? So now you could take this model and put this in your chatbot or other usages. All right.
Awesome. Thanks, Craig. So yeah, let's talk a little bit about who's using DL1 today and what they're doing. One of our top customers today is Mobileye, that many of you will have heard of. They're a leading innovator in the autonomous driving space. And so with Mobileye, I mean, I love working with Mobileye because they challenge us. They challenge us to be the best version of ourselves every day and to eke out all of the performance at the best price that we possibly can. And so we did a POC with Mobileye, and it was extremely successful. And actually, it surprised even Mobileye, as you can see from this quote here, that they were expecting around a 40% price performance improvement. They saw performance even in excess of that. And so Mobileye was really excited about this. It got to the visibility of Gabby, who's their executive vice president of R&D. And it became kind of evangelized within Mobileye so that multiple teams working on all different kinds of models started to move their production pipelines onto DL1. And so these are like proprietary computer vision models, typically, for applications like detection, segmentation, and tracking. As Greg mentioned earlier, it gets trained in the cloud. Once you have the trained model, you deploy it on the vehicle, and then it's able to complete those applications in real time. And so, I mean, Mobileye is an extremely resourceful company. And what we were able to do in collaborating with them is to get them to do more ML with the same budget, and therefore innovate quicker and deploy quicker and continue to innovate and stay ahead of the curve. Another one of our top customers is Lidos, which is a technology provider for private and government organizations. And we met with Chetan Paul, and we worked on actually a number of use cases. This one talks about the computer vision use case for COVID-19 detection from X-ray images, but we also worked on some language use cases as well. And what Chetan found was that DL1 really resonated with their core values around speed, scale, security, and usability, the principles that they look for when they start to adopt new technologies. And so that's been a really successful collaboration. Chetan and the team are really happy, and we're working on finding different use cases for Lidos and their end customers as well. So I guess, Greg, we did a toy demo, then we did a real model. Let's really push this thing. Let's see what it's got.
Let's see what it's got. Remember, we have 8 of these. These are really serious processors, and we've got 8 of them to use. So let's make sure we all know how to use it. So what we're showing here is a ResNet 152 model example. And what we'll do is walk through the changes that you need to make to ensure that you're supporting distributed data parallelism. So for our models, we use PyTorch distributed data parallel. And so we'll show you how to do that. First along the way, we did talk about Habana mixed precision. So the instruction there is basically fairly easy. Now, in 2 steps, you're incorporating our mixed precision library and then setting up a convert function to convert the ops to bfloat 16. We have a default list of optimized kernels that run on bfloat 16 and bfloat 32. There's a file that you can manage to modify that according to your model. But in most cases, you leave it at the default values, and you get the best performance. Now, distributed training. As we mentioned, is doing basically three things. First is initializing the Habana communications library. So again, this is basically our version of the Nickel library. And so you're going to initialize that. We're setting up distributed data parallel. We're setting up the data sampler, and then applying DDP to our model. So let's look at some of the code examples there. So here, we're simply calling Habana's torch distributed HICL library and importing that and initializing that. We would be sending in, if the device is HPU, which it is, then we're setting the backend to use the HICL library. And we then set our number of ranks and the number of world size, which in this case will be 8, because we have 8 Gaudis. We set the distributed data sampler, so we call the distributed data sampler function here. And then finally, we're using the standard torch distributed data parallel function to apply that to our model. So all of our models on our GitHub page have this fully implemented. So for those of you that want to just try this running 8 cards, there's nothing you have to do. This is all built into our models. All we're doing simply here is pulling this out to illustrate to you what are the steps that are needed to do it if you don't have this in your model. This is fully documented in our collateral and our documentation as well. So let's take a look and get this thing running. So we set the environment variables. We go to the Torch Vision location. Now, I did apply a small code patch previously to make sure that we're not doing eval, we're just doing training in this case. And then the only difference here is the execution script itself. So I want to draw your attention to the beginning of the script. So you'll notice here we're using MPI run. So MPI run is a standard, industry standard that manages multiple workloads. And so this is managing how the data is running across all the devices. Because we're using distributed data parallel, what this is doing is, as it says, it's data parallelism. So all 8 cards have the full model, but each card has a portion of the data. So each card trains on its own set of data, and at the end of the training run, we run an all reduce command, and that sends all the weights that are required back through the model, so the model's fully updated. And we do it again and again and again until we reach our targeted accuracy and performance. And in this case, when we use MPI run, you always set the number of workers. So in this case, we have 8 Gaudis, so the number of workers is simply 8. And then we run the traditional Python command, so train.py. So this is a standard Torch Vision model. So we're simply calling train.py, ResNet 152. Again, the device here is HPU, as we talked about before. And the rest are the standard, fairly standard hyperparameters that are required for tuning. So we have all this built in this demo ResNet script, and let's kick it off. Now, the most important thing to notice is right here. So you'll see here distributed init, and you'll see rank 0 through 3 and rank 4 through 7. So now we know that all 8 cards are being used and utilized. And the model then will continue to train, and you'll see creating data loaders, creating model, and start training. So that we'll let that run in the background. When we get a minute, we'll come back and take a look at it when it's completed. But the key point here is that we showed, again, a very simple example of a few lines of code to add to your model to get all 8 Gaudis working together.
Awesome. So thanks for those presentations, Greg. That was really exciting to see the range of stuff that we can do on DL1 today. And as you have all seen, we have customers running some of their most sophisticated workloads on DL1 today, and they're continuing to scale them to multiple accelerators like we saw today, but indeed to multiple nodes. We have customers running tens up to hundreds of nodes at this point to really improve the ML training throughput and achieve state-of-the-art performance and beyond. And so we're excited for where DL1 is going to go next, and we're excited to see what you all are going to build on it as well.
Absolutely.
So with that, if there are any questions, thank you.